Functions, what they are and how they work. These are important to understand because you'll run into them many times in math. Now, if you look it up online or in a textbook, you'll find a really long and ugly definition. But in essence, a function is just a special relationship where you have a bunch of inputs and a bunch of outputs, and they're mapped such that each input has only one output. And usually what you'll be dealing with is a function that takes an input and returns an output by applying rules or a set of steps to the input. And this is a very important thing to keep in mind, so I'll repeat it again. Each input has only one output, and usually you can represent functions using equations, graphs, tables, lists, and other stuff. And when you're graphing, you'll graph it so that you have y equals f of x, where your x-axis is your input and your y-axis is the output of your function. Now, I just said y equals f of x. Let's talk about what f of x means. Now, if we've got this function over here, f of x equals 2x plus 1, this means that function f takes an input, x, and its output is 2 times x plus 1. Let's take a little time to take an even closer look at just what f of x means. We can break this into two distinct parts. So on the left-hand side, you've got f, and this is simply the name of the function. This can be really anything, and sometimes when dealing with multiple functions, you'll see g of x or h of x. These are just commonly used letters to name functions, and that's literally all there is to this first letter here. Now looking to the right, you'll see x in a set of parentheses. The variables within the parentheses tell you what the inputs are. So when you see the same letter in the subsequent equation defining the function, you'll know to plug the input into said letter. Also, fun fact, you don't need to know this at all, but one of the reasons functions are written like this is because you can have a function with multiple inputs. You just have to separate the variable names with commas in the parentheses, like on the example on screen. This would be an unpractical function that just returns the sum of its two inputs. Okay, so now let's go back to the full equation we were just at a few seconds ago. F of x equals 2x plus 1. And as I previously stated, we plug in whatever the input of our function is into the x, and the result on the right-hand side would be the appropriate output for this specific function. So, for example, if we just say we have an input of 4, you could say that f of 4 equals 2 times 4 plus 1. And all we did here was replace the x with a 4. And you can quickly do the math to arrive at the conclusion that f of 4 equals 9. And that's our output. And one of the most common ways to represent a function using a set of inputs is with a table. And so we can have this empty table here representing our same function with inputs 0, 1, 2, and 3. What we can do is just find the output for each of these inputs and arrange them according to their inputs, like so. And then we can also represent functions as graphs, where y equals f of x. This is perhaps the most important thing to understand here. To make things quick and easy, let's keep this table on our side, and the best way to draw a functions graph is to plot a bunch of points from a set of inputs and outputs, and then to interpolate and extrapolate the rest of the graph. Or in simpler terms, filling in the gaps and predicting where else the graph may go beyond your plotted points. Our set of inputs and outputs will be this table right here. So let's go ahead and plot some points. So first we've got 0, 1, and then 1, 3, 2, 5, and 3, 7. And you can kind of see a pattern right here already. You've just got a line. And so we can just draw the rest of the line there. Sometimes you'll run into sets of inputs and outputs that just don't work. This is almost always because it'll appear that one input has multiple outputs. This is a no-no. When you run into this, know that what you're dealing with is not actually a function. With tables, you can spot this by looking if an input is repeated twice and gives two different outputs. On graphs, you'll use what's called the vertical line test. The idea is to be able to draw a vertical line through the graph at any point and only hit the actual graph once. If at any point a vertical line can touch the graph more than once in different places, then the graph is not representing a real function. Take a look at the following examples. I'll try to visualize the testing for you. But Also, try to figure out on your own which ones are not actually functions. I'll leave the answers in the description if you want to check. I want to pause here for a little bit and explain why this is a function, because that might be confusing for some of you. So, just because there isn't an obvious pattern based on whatever inputs and outputs you're given, it doesn't mean that that's not a function. You could just not know the rule. The rule could even be if the input is A, then output B. If it's C, then output D. It doesn't necessarily have to be a pattern that you can easily spot. At this level, as long as each input only has one output, you should be safe to assume that that can be a function. And that should be all you need to know about functions, at least at an Algebra 1 level. If you have any questions, let me know. I'd be happy to answer. I hope you learned something.